A week or two ago, people were scratching around for what we should do for a talk today. Someone suggested that they'd like to hear a general overview of how the internet works. Someone else suggested that I might know how the internet works. So I'm going to try and explain to you how the internet works. It's a massive topic, obviously. The internet is very big, it's very complicated. So I'm going to make quite a lot of simplifications. For those of you that have seen the IT crowd, this is the internet. This black box is presented as the internet. Obviously, the internet is a bit more complicated, and I'm going to give you guys a bit more grounding than Moss gives Jen on how the internet works. This MWUG is the internet. This is a bunch of racks of servers in a data center. That's the physical infrastructure of the internet. A server, these boxes, or lots and lots of these boxes, you get the same thing if you came to us for hosting, if you went to Amazon, if you went to WordPress.com, wherever you're going, they kind of look like that. They look a little bit different, but that's generally what's going on. The data center they sit in is a huge, air-conditioned, ridiculously power-hungry building. I don't know why that guy's sat there. He'll be cold because there's cold air coming up from the floor. These things are loud. I don't know why he's got a wheelie chair in there. That doesn't happen. But it makes a nice photo. So that's the servers that run the internet. We'll come back to them in a bit. This is also the internet. This is a lot of wires. This is a place in San Francisco, which is one of the sort of the three real hubs where everything joins together. The internet is an interconnected set of networks. That's where the name comes from. The places like this place in San Francisco, or I think it's, beg your pardon, it's in Los Angeles, are where they join together. So that's what makes it the internet. The sort of three biggest are this one in LA, there's one in New York and one in London. But they're all around the world. We have them here in Manchester, they're any city you care to name. Everything plugs together and we all make the internet. We need to talk about IP addresses, which some of you will have seen, hopefully most of you have seen. We're using version 4 of IP addresses at the moment. There's version 6 we'll come on to in a bit. We skipped 5. Just because we did. An address is 32 bits long, so that's 32 ones and zeros. They look like that. You probably haven't seen them look like that, but that's what a computer thinks of them as. Computers like binary, ones and zeros, so that's an IP address. We look at it as 4 numbers that we can read a bit easier. An IP address identifies a particular machine on the internet, so any of those servers that we saw before, they all have their own address. Your home broadband has its own address. This computer has its own address. Your phone has its own address. Everything has its own address. And everything needs its own address, because if things have the same address, how would we know where some data was going? Still on IP addresses, we have a map of the world. The first part of that address, you might remember, was 66. In this case, a lot of these numbers are made up. Please don't pretend that, I mean, 80 does become part of Europe. I don't know if 149 is Africa. It's an example. 66 is Canada. There's a lot of others that are Canada as well, but 66 points to Canada. So that gets us that far. The next one was 155. Well, that gets us onto the west coast of Canada. In fact, it gets us to Vancouver. Next up was 40. 40 gets us to, in my analogy, this street in Vancouver. So we're getting better. We're getting down to the particular machine. We've narrowed it down to a street. Streets have houses. So we get to number 249 on the street. So that's an IP address. It's a way of narrowing down where something is. You could sort of think of it like I have as country, city, street, house on the street. It's a good enough analogy for now. The signpost on the end is a router. You all have those at home, and we'll come to that in a minute. So we have a problem with IP addresses. As I said before, they're 32 bits long, which means there are 4 billion of them. Sounds like quite a lot. But there are 7 billion people in the world. You're probably carrying, let's say, a laptop, a phone. We've got tablet computers around. 4 billion is not enough. There are way more devices in the world than that. So there are 2 solutions to this. First is we can use something called NAT, where one address is shared by lots of devices. This is typically what you'll get at home. You'll see addresses like 192.168. Those are the addresses inside. Your router is using another address, and that goes out to talk to the internet. It's a bit like extensions in a phone exchange, so you can call an office and they'll put you through to an extension. You have one address that's your house or your internet connection, and everything inside that has an extension. That's the really common way. We're all using that at the moment at home. The much better solution is IPv6, which is the current version of the internet, as some people would say. Really, we're getting there. Maybe 15% of people are using it now. BT are just starting to roll with it, so it's starting to get popular in this country. IPv6 has 128 bits instead of the current v4's 32. That's enough for an IP address for every atom on the surface of the Earth for about 100 planets. So hopefully we're not going to run out of those anytime soon. Right, that's enough about IP addresses. You have at home a router. This is a picture of a BT home hub. You might have something from Virgin, something from Sky, a Linksys router, who knows, something along those lines. It's free with your broadband. It'll do something like 300 megabits a second of traffic or so. It's quite small, you know, a little device this sort of size. Doesn't use a lot of power, just a wall wart. It's a pretty simple device. All it really knows what to do with data that you send to it is to send it onto your ISP. BT, Sky, Virgin, whoever it is that you're using. ISPs and people like us, web hosts, have similar things. They look like that. They're about this tall. They weigh a lot. They cost a couple of $100,000. They'll do 14 terabits a second, which is 14 million megabits a second. So they're a bit more powerful than your home router. They're pretty big, like I say, this kind of tall, and you can get bigger ones that are sort of 6, 7 foot high. They use a lot of power. They go in those data centers we talked about before. They're very high power devices, and they're very sophisticated. They know a lot more than your router. So we're going to talk about routing, which is what they do. Routers know how to get to other networks. If you think of the signpost at the end of the street of IP addresses that we had before, had signs to go to everywhere. So a router knows those. So it knows, it has the big table of how everything's connected. That's constantly changing if you imagine people are unplugging wires, plugging wires in, adding new things all the time. And that update gets sent around the internet to all the routers, so they're always working to know how to send everything to wherever everything is going. Your computer sends your traffic up to BT. BT has several of these big routers, quite a lot of them, and they know how to get to one of the sort of, oh, what have I done here? One of the transit providers who own the cables under the sea and the satellites. Let's say level 3, they're one of the world's biggest. They'll know how to get that traffic to wherever it's going next. They know that there's someone called Peer 1 who run a bunch of servers. So they send it on to Peer 1. Peer 1 know that there's a server somewhere with WordPress.org sitting on it. So they send it on to WordPress.org. This is what happens when you type in WordPress.org on your browser. All this is going on in the background. You don't have to worry about it, but that's what's happening. This is how the internet works. The next thing we're going to talk about is DNS. DNS is the internet's phone book. You know the name, it will look up the number for you. The number is one of those IP addresses. This is sort of a little excerpt, if you like, from the DNS phone book. You've got the one for WordPress.org, which we talked about. It can have multiple IP addresses. That's fine. There's one for Google, one for us, 34sp.com, one for MWUG. Next, we need to talk about HTTP. I promise I'll tie this all together in a bit. HTTP, you'll have seen it at the start of addresses in the address bar in your browser. It stands for Hypertext Transfer Protocol. Hypertext is the thing that makes web pages work. You'll know it, starts with HTML. You'll recognize it when you see some in a minute. And this is how it's sent around. So, having done all the DNS and everything else, your computer sends this request to the server running WordPress.org. Just sends that down the wire to the server. The server sends back this lot. In your browser, or if you've changed a theme in WordPress, or done a bit of markup. This is a very small web page. It's just got the title of Move Permanently, but this top part tells your browser to go off and get this address, which is actually the WordPress.org site, served up securely. We have a little talk about SSL, because as we saw earlier on, WordPress.org serves over SSL these days, and quite rightly so. So should you. Everything should be SSL. If it's not, talk to your host. They should help you with that. You should be using SSL. It's really called TLS, but everyone calls it SSL, so we'll stick with that. What SSL does, before sending the data out to your router, it will encrypt it. It'll make it unreadable to your router, or to any router that's in between. We saw it was going through a number of routers on its journey. Any of those routers could potentially be somebody bad who wants to look at your data. That data might be as innocent as my first WordPress page. It might be credit card numbers. It might be your login details for Amazon. It might be your Google details. It could be anything. And this is why we want to use SSL everywhere. It's important to encrypt everything. So SSL will encrypt the data on your computer and send it to the server. And the server will decrypt it at the other end. It stops the routers in the middle, as I said, from seeing what's in that traffic. Routers are normally the big things we saw before. A router could easily be some hacker with a computer. That can still behave like a router. It's not too hard to have that intercept all the traffic going through. Your credit cards, your logins, anything like that. You need a certificate to do SSL. This is effectively the key to the encryption. It's what makes the encryption private. You can buy them if you're mad. These days you can get them for free through people like Let's Encrypt. Let's Encrypt is fantastic. It is literally just free SSL for everyone, and we love it. I think I'm right in saying most website providers these days will make that very easy for you to do, certainly free, nobody charges for it. It should be one click, or it should be no clicks if it's automatically set up. If you're running your own server, it's also easy to do. There's a thing called CertBot which will do it for you. But this is what a certificate looks like, but in better resolution. You can see that when you click on the padlock in your browser. About 2 clicks later, you'll get to this, and that's the details of the certificate. It will have things like, that says it's for WordPress.org, says that it expires at the end of this year. You have to renew the certificates. Again, your host or your developer should do this for you. This is the fingerprint of the certificate, a bit technical, but you could use that to verify it's real if you're feeling paranoid about things. But that's all automated for you. That's what an SSL certificate looks like when you look at it in your browser. HTTPS, which you'll see at the start when you get the padlock, is very similar to how we've been doing everything else. You look up the address in the DNS, that gives you an IP address. You route it somewhere, you send your request to the server, this time using HTTPS. All that is HTTP SSL. You will see the green padlock in your browser and HTTPS on the start of the URL. And then you get the little zap if you're using something nice and modern like HTTP2. But that doesn't matter, that's still HTTPS. It's just the same as you've used before. Your computer sends the SSL request into the internet, back to the server. It decrypts the SSL. And the whole thing happens, like we said. Exactly the same as it happens before. What do we have next? Web servers. So that's coming back from a web server. Web servers are those machines we saw earlier on. They're no different to your home computer, really. They just look a bit different. They're probably higher power, maybe more storage, more memory. But really, they're just the same as the computers you're using at home. They run a program called probably Apache or Nginx. If they're running Windows, they might run IIS. There are a few others, but really, Apache and Nginx are the two that are normally in use. They receive that request that we saw before, the GET request, and they'll do something with it. That something could be all sorts of things. They might just send back the contents of a file. That might be an image, it might be some CSS or a piece of JavaScript. And that's fine, that's a perfectly valid way for them to get that data to you. They might do something else with it. They'll serve static files by default, as we said. Images, CSS, JavaScript, which can be great, they can be very pretty. They can be really useful if all you want to do is just give out a bit of information. But they're of limited use. They won't do anything particularly interesting. They'll just return to the browser will display them, you'll get the same picture every time. And that's fine if that's what you need, but the world would be a boring place if that was all you needed. So coding can do something interesting with it. It can depend on the input the user sent. Maybe they've sent a post to put onto your WordPress website. Maybe they've sent your name, so a Hello World site can tell you what your name is. Maybe it's sent a query to Google so you can find your favorite pictures of cats. Whatever it's sent, they can work with that. You can code in lots of languages. We're all liking WordPress, so PHP is the language of choice, but there are others. There's Python, Java, Ruby, 10,000 other languages. These are sort of the most popular 4 that I grabbed from GitHub earlier on. So that's just a bit of HTML. It's coding of a sort, but it's a static web page. If a server sends that back, you'll get cat.gif, and you'll get a picture of a cat. But every time you look at that page, you'll get the same picture of a cat, which is nice, it's a pretty cute cat. But you're just going to get that picture of a cat. So if we do a little bit of PHP, this is 2 files now. So we have a bit of PHP here, a really short PHP file, and then we have a little HTML page, a bit like before, but instead of just the GIF, it's doing a PHP file here. So I stole that from Stack Overflow. I haven't run it. Please don't tell me off if it doesn't work. Look, it looks like it'll work. So when you run that, you get a picture of a cat. This is my cat Doofus, being an idiot on my sofa. You'll get a picture of a cat. If you run it again, because this will give us a random image, you'll get a different picture of a cat. Smire the cat Fisher. And if you run that a bunch of times, you'll keep getting different pictures of cats. Coding can do something interesting. It can do something different. You don't have to get the same picture every time. It can also be pulling things out of a database. It can be storing things in a database. For instance, it could be pulling WordPress posts out of a database, or adding WordPress posts to a database, or dealing with a login. This is a very short, what's that, sort of 8 lines of PHP? Yeah, that's not a lot of PHP. So let's talk about WordPress at last. That's why we're here after all. As of about 5 o'clock this afternoon, WordPress has about 180,000 lines of PHP, not quite the 8 lines that will give you a random cat. It has 89,000 lines of CSS and nearly 56,000 lines of JavaScript. There's a lot of effort has gone into WordPress. I know some people here have contributed some of that. Maybe some rather large parts of that. And it's a huge thing. But it's just coding. It's the same as the random cat GIF generator. It's a bunch of code. It deals with a request that you've sent it from your browser, and it sends back something. That something is a WordPress page, but obviously that can be, it can have themes, it can have plugins, it can be posts or pages or anything you like. You can do anything with it. So, to get as far as WordPress, we've used DNS to find from the domain name you've used. You get to the IP address. The IP address you send to your router, and your router routes that over the internet. It knows how to get to the server. You send that HTTP request to the web server. The web server runs the WordPress code. The WordPress code will look in the database, and it will pull out your posts and your theme and everything else that it's doing. And in the end, you get that. You get the Hello World page, and WordPress has worked. Fantastic, that's how you get to WordPress.